All right, guys, as you can expect, we are going to be working around equipment, and this equipment is going to be fairly large. It's going to be very substantial, and sometimes the equipment can actually stand 2 stories, if you would believe it. And that just really depends on the facility and the manufacturer that you work with. But these things are not small. These things are very, very larger than life when I go into a workplace and begin to work in that type of area or manufacturing facility. So big, complex equipment, folks, is a thing, and I have to respect it because it is very large. It can be very dangerous. Things can go on in there, and it could really be a very drastic safety hazard if it is not getting maintained and kept in a certain way. So when I work with the equipment, very often in pharma and biopharma, we get this idea that things have to be cleaned, and things have to be more than just, oh yeah, it looks good. We really do have to give it a very good dousing, a very good scrub-a-dub, and we're going to have to probably sanitize it too at some point in fashion before we use that piece of equipment over again. These are very common things that have to be done, and for that reason, we're going to be on the inside sometimes cleaning or doing things in these big vats or in the big equipment that I'm utilizing. Equipment can also come in more than one type of version. We could be seeing very large centrifuges. We could be seeing very large filtration systems, and all of those are going to have to be cleaned. They're going to have to be maintained. We're going to have to make sure that things are going according to plan. Mixing and blending is also a thing. I don't want to be in a mixer and a blender cleaning it and then that mixer and blender getting cutting off, because then they're going to have a Tracy smoothie by the end of that spin down. So there's got to be a proper way that we handle the equipment and that we work with the equipment in a very safe manner. So any energized equipment has to properly be what we call de-energized. And de-energized basically means electricity. So if this has a power source, we're going to have to make sure that we turn that power source off and preferably unplug it if we can. Now, sometimes we can't do that, but if we can flip a breaker off, or we can do things to ensure that that power cannot be restored without going through some extra hoops and hurdles, then this is going to be way safer, and I'm not taking as many risks crawling inside of that blender if that's something that I'm going to have to do. So these things are going to be a problem, and there are ways that we handle this type of equipment. There's ways that we handle it and do things in a very safe manner. And OSHA is going to help us out with this. And Title 29 CFR 1910 blah 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 does not matter the number. That will never be asked, folks, but Title 29 maybe. So Title 29 looks like it's a lot of this OSHA stuff. OSHA is going to give us the control of hazardous energy, and they're going to kind of give us an abbreviation called lockout tagout. So it is the idea that I can go inside of maybe my home and I can do some maintenance on a stove. And before I do maintenance on a stove, I'm going to unplug it. And if I can't unplug it, then I'm going to flip a breaker to cut the power source off. And then I can do some work on the stove in my kitchen. If I want to replace a light switch, that's great. I can replace a light switch. That's not a problem. But I can't do that with the power on, sending electric to that light switch. So I'm going to have to cut the power off, or that breaker at least, and then remove the light switch, disconnect the electrical cords, put the new light switch in, and then put it back into the wall. That is de-energizing these sources that need maintenance or a little bit of work. So these are areas that we're going to be focused on in this portion of section 2.8, which is called equipment hazards. Some hazards, again, are going to be electricity, absolutely, but plumbing is also an issue as well. So any type of water source that might be there. Folks, there's a number of different things that have to happen depending on the piece of equipment that we've got to be working with. But lockout tagout is the proper procedure that is used to make sure that everyone understands not to use that piece of equipment, because that equipment's undergoing maintenance and something is going on with it, and I don't want to be trying to turn it on. I don't want to be using it for a shift because I didn't know any better. So in these bigger facilities, we've got multiple shifts, we've got plenty of people working in a certain area. It's very hard to kind of keep everyone on the same page, and we do not want to take the risk of someone basically being going, oh, I didn't know, I turned the power button on and I made a Tracy blender smoothie. I don't want that instance to happen. So lockout tagout is going to be a thing. So what you're seeing here is probably an on-off button, and they have made some type of system or device here that looks like it's got multiple holes. It's like a little piece of Swiss cheese or a little cracker. And then in one of those holes, I see a lock, and that lock, of course, lock out, tag out. Oh, I gotta have lock and I gotta have tag. Yeah, absolutely. So there's my lock and here's my tag. So it says danger, do not operate, and it gives me blah, 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 blah. So it gives me a way to maybe fill out some information to let people know what's going on, write some kind of note there so people are aware not to use that piece of equipment while we work with it, while we clean it, while we maintenance it, while we troubleshoot it, and so forth. So this is a lock, and that lock cannot be taken off. It can only be taken off by the person that put the lock on there. So don't go around and being like, hey, do you know where that key is? I need to take it off. No, that's not how any of this works. But you know, it's on there for a reason, and that's to make sure no one accidentally cuts it on. So why would we accidentally let you have the key to take the lock off? It's not going to work that way. So there's multiple holes here because actually multiple people maybe could be doing some maintenance on this at the same time. So if there is a water source that's a problem, if there's an electrical source that we've got to shut off, well, maybe someone in charge with the electrical types of devices will have their own lock, and maybe a person with in charge of maybe plumbing and water sources, they are going to have their own lock. You know, different people will have different reasons to do things onto certain pieces of instrumentation or equipment. So that's why you often see these multiple holes that are there for multiple locks. Sometimes those locks are color coded, so you'll know which person has done what and who is left over to do their job. But folks, the idea here is to lock out and to tag out equipment. So put a lock on it, put a tag on it. Please don't ask any questions. It's under maintenance. Don't turn it on. Don't try to use it because it's not going to work out for you. Different instrumentation has different types of locks that might need to be placed on there, and we've got locks for everything. We've got locks for circuit breakers, we've got locks for light switches, we've got locks for turning on and off power switches, we've got locks for valves that need to be turned. So there's a number of different things that are out there that's available to ensure that people cannot accidentally turn on things that should not be turned on, because these are now out of commission, at least until the repair or the cleaning or the maintenance has been performed. Live electrical energy is a thing. Prematurely re-energized equipment, stored energy sources like hydraulic or pneumatic pressures, and thermal energy are always a thing here. I don't want to be crawling into something that still has some energy left over and that it's going to basically push down on me and make me into a little Tracy sandwich. Again, I don't want to be falling into a blender and accidentally having that cut on and making a Tracy smoothie. I don't want to be doing these types of things in the workplace or in real life. And the only way to make sure that we can help prevent those types of mistakes from happening is through lockout and tag out. So procedures for equipment, number one, we're going to completely stop it. So it all just gets turned off. If there is a power button, of course, we're going to turn the power button off. Number two, we're going to isolate the equipment. So very often, if it's on wheels and if it can be moved, then we're going to isolate it. We're going to take it into its own place. We're going to make sure that it's out of commission, that it's not really easily accessible. We're going to isolate it in some form or fashion. If it cannot be moved and if it's got to stay in its location, then we want to make sure that we put some kind of safety perimeter or safety barrier around it, even if it's like a little caution rope like you see at amusement parks or that you would see at at maybe airports. Just rope it off so that way people know not to use it. Don't go back there. It is not allowed. Something's going on with it. Number 3, switch off the main breaker. So we're going to go over to the breaker. If we can find it, it probably is one. It's easily accessible. You might not have that responsibility, but somebody will have that responsibility, and they will flip the breaker off so that way accidental power buttons cannot be switched on. Again, it's another safety feature. You would do that at your house. You would do that in the workplace as well. If there is a plug, then absolutely you unplug it from the outlets. So that is often another kind of safety feature that goes on. Again, it is another layer of safety and protection that we can do as we're doing maintenance on some of the equipment. Number 4, we're going to verify that all of the energy is now off. So we're going to try to turn actually the power button back on. We're going to try to get it to do some type of movement or some type of work that it is meant to do. And it should not be doing it at this moment. If it is doing it, then we've got a problem. We need to go back to step number 1. If it's not doing anything, then that's great. That means there's accidents that happen and someone's in it or someone's doing maintenance or whatever the case might be. They're not going to get accidentally smoothitized, and they're not actually going to get a sandwich made out of them. Number 5 is release any of that stored energy. Number 6 is attempt to start it. So if you can't start it, that's another good sign. You shouldn't be able to start it at this moment. And then number 7, we finally put a lockout tagout kit onto that system. So I think it's very important for me to say here that we go through all of the other motions first. We want to make sure that the power's off, that the thing's not working, that it's been de-energized. I've tested the power button on and off. It's still not working. All of it looks good. It's ready to go. I think it is now safe to work on in some form or some fashion. Only until those steps are completed do we then put the lockout tagout kit on the back end. And that's because this is the way that people know there is something going on with that equipment. It cannot be used. And up until that point, if I did not double check everything like this, then a lockout tagout kit could go on it, and then maybe we did not fully de-energize it, and then accidents still do happen even with lockout tagout on it, and I could be turned into a smoothie or a sandwich at that point. And I do not want that to happen. You might want that to happen, but I don't want that to happen. So lockout tagout is one of the very last things that we do, and that just really kind of seals the deal and says, no, this instrument's out of commission. It is now no longer working. We have double checked it. Absolutely, it is no longer working at all. Lockout tagout procedures. Remember, equipment can have more than one lock, and that's okay. No one says that it can only have one lock and one lock only. Again, it really depends on the nature of the piece of equipment and what we've got to do with it. Next up, never remove someone else's lock. That person put the lock on for a reason. They are responsible for that lock. Even a freaking supervisor cannot go in and take the lock off. They actually are required to call the person that put the lock on in order to have that same person take that lock off. It is a very heavily controlled system. And for that reason, they are very particular about who puts it on and who takes them off. Again, this might not be your job responsibility. You might work for these companies and you might never have to put a lock on a piece of equipment at all. You are not part of the log out, tag out crew. And if not, that's great, but somebody will be doing it. Do not think that you can go to a supervisor and say, I need to use that over there, please. Call that person and have them take that lock off. That is not how any of this works. They are not allowed to do that. These things are heavily controlled by OSHA because it is a OSHA regulation as far as safety goes in the workplace. Next up, be patient. So these things are going to take a while, and sometimes it takes longer to do the lockout tagout and to go through the motions of proper startup than it is taking for the maintenance to be repaired or the cleaning to take place. I mean, that is something that goes on. So maybe that procedure that needs to happen will only take 15 minutes. And that's great, but maybe by going through all the hoops and all of the sign-offs and all of the forms, all of that is going to take hours worth of work. That is just the trade-off when it concerns safety. We put safety first, not convenience. That's always the thing. Safety number one, not convenience, just because you want to make a quick little fix and then go on about your business. That is not what happens with lockout, tagout. All of these steps are required for a reason. All of the forms are required for a reason. It is heavily controlled for a reason, and all of that has to stay true to the regulation. Next up, it says follow the proper procedure to bring equipment to a zero energy state and to prevent others from accidentally turning it on before it's safe to do so. So again, the idea of double checking it, make sure that no energy is accidentally getting through, make sure that everything is unplugged, breakers are off, things have been isolated, things have been roped off, so no one can accidentally get into those areas thinking that that thing is going to work, and it's not going to work at all. So all of this is the idea of lockout, tagout. Again, it's very common in most industrial settings. But pharma and biopharma is one of those industrial settings. So, of course, we're going to see it in there. But any industrial setting, it does not matter if you're pharma or biopharma, will typically go through lockout and tagout procedures and protocols. Equipment has hazards. Absolutely, they do. We got to work safely around them when we come in contact with them, when we're using them, shutting them down, starting them up, doing maintenance on them. And there's two things that really happen here that help us with this job, and the first one's called an interlock and the next one's called an alarm point. An interlock is just something that will not allow you to do something until levels are at the appropriate level. So I've already kind of mentioned interlocks as far as maybe like a pressurized system. So we're working with pressurized systems. They're out there. We've got high pressures that are associated, and then that procedure is now finished. So we slowly release the pressure. That goes on. So as we're slowly releasing that pressure, then that valve will go lower, 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 lower. If that pressure is too high, then maybe we cannot open that vat. We cannot open that valve up even more. We cannot do any type of maintenance or get to our material that we need to get to. That is an interlock. So that interlock is relying on a safe level before that interlock opens up and allows a user to have access on the inside. So that's just one example of an interlock. There are many more, but that is the purpose of an interlock. So it is a safety feature on equipment that allows us not to do things prematurely. Next up is an alarm point. An alarm point is an alarm that is allowing you to be notified when a certain set of conditions are happening. So, for instance, if there is a temperature alarm point, that temperature should not be above 80 degrees. Let's just use that as an example. So if it does go over 80 degrees, that is an alarm. That alarm is going to sound off. That will be a very annoying alarm because they want your attention. They want you to go to it. They want you to address that problem. That is an alarm point. That is not an interlock. So just because something is maybe hotter than 80 degrees, that is okay. The alarm's going off. The alarm is telling you that that is a problem. But actually, if there's no interlock in place, you could do something stupid. And if you do something stupid and you open up a vat with super hot stuff that's now right in your face, then you're going to get some scalding. You're going to get some burns. You can go to the hospital. So interlocks are different than alarms. Alarms is notifying you that something is a problem or could be a problem. And the interlock is a built-in safety measure that is making sure that you don't do things prematurely or you don't do things by accident unless certain conditions have been met. And those conditions can be a number of different things. Again, I use pressure as an example, but it can be a number of different measures that are there in that work setting or with that piece of equipment. All right, so that's a little bit about equipment hazards, section 2.8. The idea that lockout tagout is out there. We've got a lockout tagout kit in our laboratory setting. You're more than welcome to take a look at that, get a closer feel of what goes on, kind of the rhymes and reasons, different variations of the locks that are out there in existence. So just let us know. We'll kind of show you what those things look like. And then the idea of how to safely do a lockout tagout and some of the rules and regulations about the lockout tagout procedure. So interlocks, alarm points, all very important. And in the next video, we're going to focus on section 2.9, and that's going to be our surrounding areas. So, you know, we talked a little bit about the work area, what I'm working with, what's around me, but now the surrounding areas, you know, the space itself, that is the surrounding area. What kind of safety things do I need to keep in mind as I'm working in these spaces? So that's where we'll pick up in the next video.